All right, we're looking at probabilities using counting principles today. These counting principles, like combinations and permutations, like we talked about earlier in our class. But let's look right at one here. Number one, a delivery route must include stops at 6 cities. If the route is randomly selected, find the probability that the cities will be arranged in alphabetical order. Round your answer to 5 decimal places. All right, so there's 6 cities. All right, so first what we need to do is to do a probability of our cities being in, I'm just going to put alphabetical order, like that, AO. All right. On top, we have to find the number of desired. On the bottom, we have to find the total number. Okay? Now, what we're doing here is we've got these 6 cities, and what's desired is for them to be in alphabetical order. Well, there's only one way that they can be in alphabetical order. There's only one way. You can't have A, B, and then D, and then C. It has to be A, B, C, and then D. So they have to be in order, and there's only one way to put these 6 cities in order. So on top, what's desired is there's only one of those. Okay, now on the bottom, the total number, since there's 6 cities, what's the total number of ways that we could go to these 6 cities? All right, well, there's 6 of them. And we're going to go to all 6, and this would be a permutation. So, and as I told you before, when these two numbers are the same, that's just 6 factorial. So this is 1 divided by 6 factorial. Okay, so we get the calculator in here. We'll punch it in. All right, let's see here. 1 divided by, okay, and then I got to do math, and then I got to go over here. Right there is factorial. 1, I didn't hit my 6. 6 factorial. There you go. And it should be that right there. 00138. 00138 is what my calculator says. And looks like this one right here. I think if you look after the 8, there's another 8 after that 8, so this 8 will make that 8 go up to 9, 00139. And there you go. Okay. Number 2, a tourist in Ireland wants to visit 7 different cities. If the route is randomly selected, what's the probability that the tourist will visit the cities in alphabetical order? That's the same problem we just did. So, probability that they're in alphabetical order. These 7 different cities. Okay, well, as we just mentioned a while ago, there's only one way to do all 7 in alphabetical order. There's only one way for them to be in alphabetical order. On the bottom, there's 7 cities, and we're going to go to all 7. That's the permutation, and when these numbers are the same, that's just 7 factorial. So that should be my answer right there. All right, so I'm going to punch this in. 1 divided by 7 factorial. Okay, now look here what this is. This has gotten to be real small, so it's converted into scientific notation. You see this is e to the -4, which means this moves back 4 places. So if I move it back 4 places, I'll have 1 to be in front of the 1. Then I'll have to have 3 zeros, so 3 zeros. Okay. And then I'll have this 198. And then I'll have the 4. And then 126. And that's probably enough. So there's what my answer is from the calculator. So that's how you determine what this is. When it's -4, that means this is moving back 4 places. This is scientific notation, which is really this right here, 1.98 times 10 to the -4 is how we usually do it. But it doesn't do the times 10. It just puts this little e on there and then puts -4 instead of the times 10 thing. Anyway, this says round 5 places, so 1, 2, 3, 4, 5. This 8 makes the 9 go up, which makes the 1 go up to a 2. So it looks like this one. And you can see the answer right there. So we're right. Okay. Go to the next one here. Okay, a committee has 14 members. There are 2 members that currently serve as the board's chairman and ranking member. Each member is equally likely to serve in any of the positions. 2 members are randomly selected and assigned to be the new chairman and ranking member. So we're going to select 2 new ones. What's the probability of randomly selecting the 2 members who currently hold the positions of chairman and ranking member and reassigning them to their current positions? All right, so basically what you have is you got Alan and Ben. Alan and Ben are in these positions. What's the probability that we get Alan and Ben back in it? All right, so probably I'm just going to put AB. Now I'm just making these names up, but it could be some different names. But here's the thing. To put Alan and Ben back in those positions, there's only one way to do it. Alan's going to go into that position, and Ben's going to go into that position, and there they are. They're back in it. There's only one way. You can't switch them because then that'd be different. And you can't put somebody else because that's somebody different. You want these 2 people, and there's only one way to get those 2 people back in it. So the desired is just one way. Just one way to fulfill the desired. Now on the bottom you have the total. Okay, now there's 14 members, and it says on here that each member is equally likely to serve in the 2 positions. So of these 14, we're going to select 2 of those. Okay? Okay? Which means this right here. This is a permutation of those 14 people selecting 2, because the order matters. See, AB is different than BA. So this is going to be a permutation on the bottom. So of the 14 members, we want 2 of them to fill these 2 spots, and the order matters, so it's a P. And now if I punch this in, this would be 1 divided by this 14 NPR2. So here it is right here. 0.0054945. Okay, that's plenty. This says round it 4 decimal places. All right, so 1, 2, 3, 4. This 9 makes that 4 go up to a 5, so it should be 0.0055, which is right here. You can see the answer right there. Okay, go to number 4. Some interesting stuff. Number 4, a committee has 11 members. There are 2 members that currently serve as the board chairman and the vice chairman. All right, this is, I think, the same problem. Each member is equally likely to serve as any of the 2 positions. 2 members are randomly selected and assigned to be the new chairman and vice chairman. What's probably of randomly selecting 2 members who currently hold the positions of chairman? So this is the same exact problem as number 3 was. Okay. So in doing this, you write this out, probability AB. Let me write this out again. This is the total number of desired, or what's desired, divided by the number of total ways of doing this. And to take A and B and put them right back in as A and B, there's only one way to do that. When you have this current chairman and vice chairman to be filled back into those spots, there's only one way to do that. Now on the bottom, we have 11 members, and we're selecting 2 of them, but the order matters on this because you got a chairman, you got a vice chairman, so this would be a permutation of 11 members selecting 2. And so I'm going to divide that. All right, so 1 divided by 11 permutation 2. And this comes up right here. Let me write it down. 0.009090909, just goes on forever like that. Okay. This is round 4 places. So that means I got 1, 2, 3. I'm keeping these 4 right here. This 9 makes that 0 go up to a 1 though. So it should be this, which you can see the answer right there. Okay. All right, here's another one. Okay. On this one, a horse race has 10 entries. So there's 10 horses in this horse race. And one person owns 2 of those horses. Assuming there's no ties, what's the probability that these 2 horses finish first and second, regardless of the order? So you see, here it's telling us the order doesn't matter, just so these 2 horses are in those 2 spots. It doesn't matter which one's first and which one's second. Okay? All right, so this is a probability of, let's say, just our 2 horses. Okay? On the top is what's desired. On the bottom is the total. Okay? And what's desired here is for the 2 horses that this one person owns, for them to be first and second. All right? And the order doesn't matter, so this will be a combination. So it's a combination of his 2 horses finishing as the 2 horses. So of his 2 horses being the 2 horses that win. Okay? Now on the bottom, altogether there's 10 horses. And there's going to be 2 winners. So of the 10 horses, there's 2 winners. And this is what we'll do here to type this in. 2 choosing 2, 10 choosing 2. All right, so if I type this in, 2 NCR 2 divide by 10 NCR and 2. And I get this right here, 0.022222, and you can see the answer right there. Okay. All right, the next one here, number 6. All right. This is number 6. You look over the songs in a jukebox and determine that you like 13 of the 55 songs. There's 13 you like, and there's 55 total. Okay? Part A says, what's the probability that you like the next 4 songs that are played, assuming that a song cannot be repeated? Okay? So if there's 4 songs played, what's the probability you like all 4 songs? Okay? So it's going to be desired over total. What's desired is for you to like all 4 songs that are played. So that means of the 13 you like 13. Of any of those 13, 4 of them get played. That's what's desired. Of the 13 you like, you want 4 of those played. And it doesn't matter what the order is, so it's a combination. Now on the bottom is the total, and there's 55 songs total. So this is another combination. And they're going to play 4 total. And that would be your total on the bottom. Okay, so what's desired is of the 13 songs you like, 4 of them get played. On the bottom total, there's 55 total songs, and 4 of them are going to get played. So that's the total ways this could happen. All right, so now just divide it. All right, so 13 NCR 4 divide by 55 NCR 4, and I get this right here, 0.020964. Okay? Now it says round to 3 places. So 1, 2, 3 right here. This 9 makes that 0 go up to a 1, so 0.021. Wait a minute, no. My answer is wrong because there's 2 zeros here. There's 2 zeros, I didn't write it down. So let me write it in here. Okay, so now 1, 2, 3, this will be the 3rd place, and this 0 makes the 2 stay. So it should be 0, 0, 2. But I didn't write the number down from the calculator. It's kind of hard to see it in here. All right, on the bottom, Part B, the probability that you do not like any of the next 4 songs. Okay, now, you might think complement here, but this is not the complement. What this is, you do not like any of the next 4 songs, which is not the complement of this. This, you like all 4 songs, but the complement would be that you don't like all 4 of the songs, which means you could like 3 of them, or you could like maybe 2 of them. All right, so what we have here is you do not like the 4 songs, which means this right here. What's desired in this problem over the total, what's desired is of the 55 minus 13, if you do 55 minus 13, you get 42. Which means there's 42 songs that you don't like. Okay? There's 42 songs you don't like. So of those 42, we desire 4 of those. And then on the total, it's the same as a while ago. There's 55 total songs, and they're playing 4 total. And so that's how you would set this problem up. Okay? And so as I punch this in, okay, right there it is right there. 42 choosing 4, 55 choosing 4, which is 32818. And it says around 3 places, so I'm going to keep these 3, which this 1 does not make the 8 go up. It stays. So you see the answer right there. Okay. Number 7. Okay, 7 I think is the same kind of problem here. Instead of looking at songs in the jukebox, what this one is we've got the office of president, vice president, secretary, and treasurer for an environmental club. It'll be filled from a pool of 18 candidates. 8 of the candidates are members of the debate team. What's the probability that all the officers are filled by members of the debate team? That's like what we did earlier in the problem with the jukebox. So what's desired versus what's the total is, well, what's probably that all the offices are filled by members of the debate team? There's 1, 2, 3, 4 of them. So of the 18 people in the debate team, this is a combination, we desire 4 of those. Okay? Now in this one, we just want our officers filled, so the order really doesn't technically matter for this as far as these so I think we could just do C's. I don't know, it might be a P. The order does matter because we got these offices, and so we're going to fill them with these 18, so 8, I guess it would be P. It'd be a permutation of 18 choosing 4. On the bottom, there's 18 candidates. I couldn't find my number. 18 candidates. Okay, I've got this wrong here. There's only 8 on the debate team, so this should be 8. I'm messing up. That would be on the bottom. I'm screwing this problem all up. I apologize. But there's only 8 on the debate team, so we desire of those 8, 4 of those to be filled in those positions. And it'd be a permutation because order matters. And there's 18 total candidates. So of those 18, we're selecting 4 of them in those positions, which makes it permutation. Okay, so let me type this in, okay? So we're going to do 8, and we're going to do a permutation, selecting 4 of those, divide by, then we got 18 total, and we're doing a permutation of 4, which comes up to this. And you can see 0, 2, 2, 8, the 8 makes the 2 go up to a 3, and you can see the answer right there. On this next one, it says no offices are filled by the debate team members. So what's desired here? Of the 10 that are not on the debate team, we want 4 of those. And then the bottom's going to be the same. Okay. Now what I can do, since I just punched this in a minute ago, is change my 8 to a 10. There you go. And it comes 0686. This 6 makes the 8 go up to a 9. 069. And right there it is. Okay. Number 8. I've got this pie chart here. Shows how adults rate their financial shape. I could probably move this over some. Okay, number 8. Suppose 4 people are chosen at random from a group of 1,300. What's the probability that all 4 would rate their financial shape as excellent? Make the assumption that 1,300 people are represented in the pie chart. Now, what we have here is these percents. I can multiply these, so like 0.08 times 13. Here, I'm going to do it real quick here. 0.08 times 1,300. So there's 104 people there. 0.41 times 1,300 is 533. 0.36. There's 468 right here. 0.14. That's 182 in this one. And then 0.1 would be 13. 0.01. And if you add these up, they should add up to 1,300. 7, 15, 20, 2, 5, 11, 19, 20, 2, 3, 8, 12, 13. So they add up to 1,300. But that's how the numbers are displaced, based on the percents. Okay? Now, what this is asking for, what's the probability that all 4 would rate their financial shape as excellent? All right, there's 104 of those. So that means what's desired here is for of these 104, us to get 4 of those. And the order doesn't matter. On the bottom, there's 1,300 total people, and we're selecting 4 total. And that's what I'll divide. Okay, so if I punch this in, 104 NCR 4 divide by 1,300 NCR 4. And I get this right here. Oh, here's one that's changed into scientific notation. If you see this -5, this decimal goes back 1, and then 4 more, which makes 4 zeros. So and then I've got the 38817. So there's what my answer comes out to off the calculator. Okay, now this is round to 6 places. So 1, 2, 3, 4, 5, 6 right there. This 8 makes that 8 go up to a 9, which would be this right here. Okay. All right, just a couple more here is all we got. I think we got 3 more. I think. All right, here we are, number 9, and it's a similar question what we just did with the little pie chart here. I can multiply these up and see that on this one, the pie chart at the right shows how adults rate their financial shapes. Suppose 18 people are chosen at random from a group of 500. Was it probably that none of the 18 people would rate their financial shape as fair? All right, so I'll do the same thing I did a while ago. I'm going to do 0.04 times 500, 0.43 times 500, and so on. Okay, let's see here. All right, this is 20. This is 215. This is 190. This is 70. And this is 5. And if I add these, 5, 10, 1 carry 1, 3, 4, 13, 20, carry my 2, 4, 5. Yeah, adds up to 500. Okay, so that's how they're distributed based on these percentages. Okay, now, the question is asking, move this over a little bit. Find the probability that none of the 18 people would rate their financial shape as fair. All right, fair is right here. There's 190 of those that say their financial position is fair, which means if I subtract that from 500, there's 310 that don't say they're financial shape. Couldn't think of it. Their financial shape is not fair. So 310 say their financial shape is not fair. Okay? So of these 310, we desire 18, all 18. And there's 500 total, and we're selecting 18. And that's how we set it up. Okay? So if I punch this in, okay. Alright, so I've got 310 NCR 18 divided by 500 NCR 18. And it comes out to, alright, here's another one that's scientific notation. Alright, so it says -4, which means this goes back 4 places. So there's 1 and then 3 zeros. So I got 1, 2, 3 zeros. I've got a 1, a 5, a 1, a 0, 1, 7. That should be enough. That's what the calculator tells me. And if it says right here 6 decimal places, so it means 1, 2, 3, 4, 5, 6. This 0 right here makes the 1 stay. So that should be it right there, 0.000151, and there it is. Okay. Number 10. In a certain lottery, you must correctly select 6 numbers in any order out of 35 to win. You purchase 1 lottery ticket. What's the probability that you will win? All right, so what's desired, okay, is of those 35 numbers, okay, you're selecting 6 of those 35 numbers. Okay, so of the 6 you select, all 6 have to be right. There's a combination of that, which is just 1. When you have C, when these 2 numbers match on a C, that's automatically just 1. There's only one way to get all 6 numbers on this. See here, let me do this. I don't think I've done it before. C6 6C6 is 1. See that? When these numbers match for a combination, there's only one way to do that. And that makes sense. If you're going to get the lottery, you got to get all 6 numbers, which means all 6 of your numbers have to be right. And there's only one way to do that. And that's to pick all 6 right. On the bottom, there's 35 total numbers, and they're going to select 6 at the state or at the lottery company. So this is going to be 1 divided by 35C6. All right, so this is going to be 1 divided by 35C6, which comes up to this. Now look here, okay? Write this down, 616082221E-7 is what this says. Okay, now it says right here, use scientific notation. Use a multiplication symbol in the math palette as needed. So you'll select that on the screen. Round the nearest hundredth as needed. All right, so my nearest hundredth, 100 has 2 zeros, so these 2 places is all I keep. 6.16 times 10, and this is -7. So there's my answer. Okay. All right, number 11 here, and I think this is the last one. All right, number 11. A company that has 200 employees chooses a committee of 12 to represent the employee retirement issues. When the committee is formed, none of the 56 minority members are selected. Okay, now what we're going to do is we're going to look and see, is this right? that none of the minorities get on there. Seems like there might be an issue there that they're not having any minorities. None of the 56 minorities. So first it's telling us use technology to find the number of ways 12 employees can be chosen from 200. Well, that's from last section we did. There's 200 employees. How many ways can we get 12? So this is a C. The order doesn't matter here. So we're just going to type this in, C212. All right, so I get my calculator here. 200 C12. This comes up to right here. Now it wants us to put it in scientific notation. So we're going to do 6.1. Now the 7 makes the 0 go up to a 1. So it's going to be 6.11 times 10 to the 18. Okay. And if you look right here, that's what they got. Okay. All right, part B. There are how many ways to choose 12 employees from the 144 non-minorities? All right, so the part B says use technology to find the number of ways 12 employees can be chosen from the 144 non-minorities. Okay, so that's just going to be 144 selecting 12. All right, so I'm just going to go up here, right there where that 200 is. I'm just going to type a 144 over it, and there you go. 1.03, the 6 makes the 3 go up to 4. 1.04 times 10 to the 17. Okay, which you can see right there. Okay. All right, now part C says, what's the probability that the committee contains no minorities when the committee is chosen randomly without bias? Okay, so what that means, what's the probability that the committee contains no minorities? Well, that's what we just did right here. There's this many ways to choose 12 employees from the non-minorities. So that's what's desired right there. This is my desired. And the total way of choosing 12 employees is right here. That's how many ways total to choose 12 employees from the 200 employees. So I do this, divide by this for the answer on my probability here. All right, so I'm going to do that on this calculator here. In fact, I'm just going to go this number divided by this number. And I get this right here, 0.0169. Okay, which it says round 3 places, so this 9 makes the 6 go up to 7.017. That's what it would be right there, and you see the answer right here. Okay, now the question part D says here, in D, this is yes. The selection committee is most likely biased because the probability that was found in part C is small. This is 0.017. This is 1.7%. This is real small. So apparently, if they don't have any minorities on there, they're being biased because that's like a 1% chance that they could have that selected and not have any minorities. So they must be biased. They're not doing their thing right. Okay. Anyway, that's probabilities using counting principles. So you try these, and if you need any help, let me know. I'll try to help you all I can. Have a good rest of the day.